Hello, Prosperivarians. The best school has come to stay in the city of Calabar. It is called Beryl International School. Take advantage of this opportunity now.
Tell me the best school, Beryl is the best. Tell me the best school.
Hello students, and welcome once again to Beryl e-learning. We will be looking at math for SS1 today and considering the topic on the surface areas and volumes of shapes. We continued this topic last week, but we are yet to exhaust it, and we looked at surface areas and volumes of cubes, cuboids, and cylinders. Today we will continue with the volume of pyramids. The figure we have on the board is a pyramid having a base which is square shape. That means the base is square, so we call this a square-based pyramid. Okay, as you can see on the board, the formula for finding the volume of a pyramid is 1/3 times base area times height. 1/3 times base area times height. Like I said, it is square-based, so the base is a square. So we have 1/3 times the area of our square then times the height of the pyramid. We'll be solving some examples and applying the formula we have on the board. Okay, let's look at these examples. A pyramid 6 cm high stands on a square base of 4 cm. But calculate the volume of the pyramid. The second one, calculate the height of a rectangular base pyramid if the volume is 70 cm cubed and the base area is 28 cm squared. Call this A and B. Yes, on the first one, the pyramid is 6 cm high. The height is 6 cm. It stands on a square base of 4 cm. Its volume equals 1/3 times base area times height. From here we have 1/3 times base area times height. 1/3 times b squared times height. Where our b here is 4 cm, we have 1/3 times 4 squared times height. Because we are told that it stands on a square base of 4 cm. Square base of 4 cm, so we have 4 square. We are saying 4 square because the base is a square, just like what we have on the board. The base is a square, and we know that the square has 4 equal sides. So we have 4 square times height, and the height is given as 6 cm. Right? Times 6. So we have 1/3 times 4 square is 4 times 4, which is 16, times 6 all cm cubed. 3 will cancel itself one time. Into 6 we have 2 times. So you are left with 16 times 2, and that will give us 32 cm cubed. Remember, we are looking for volume, so it should be in cm cubed since we have our height and other dimensions in cm. So the volume should be in centimeter cubed. Let's run through it again. The pyramid 6 cm high stands on a square base of 4 cm. Calculate the volume of the pyramid. We have established a formula already, 1/3 times base area times height, and we say that the square has a base. The square is of length 4 cm, and we know that a square has 4 equal sides. The area of the square is length squared. That's 4 times 4, which is 16, times our height of 6 cm. So we have 1/3 times 16 times 6. 3 into itself is 1. Into 6 we have 2. 1 times 16 is 16, times 2 we have 32 cm cubed. So the volume of that square base pyramid is 32 cm cubed. The second one, calculate the height of a rectangular base pyramid if the volume is 70 cm cubed and base area is 28 cm squared. Now in this case, the volume is given. We establish our formula 1/3 times base area times height. But our volume is given as 70 cm cubed. 70 cm cubed. From here, say the volume is 70 cm cubed. Base area is 28 cm squared. We are now to find the height. So we say 1/3 times our base area is 28, then times height, which is unknown, equals 70 cm cubed. What do? 1 times 28, we have 28 times our height, we have 28h all over 3 equals 70 cm cube. At this point, we cross multiply. We are looking for our h. We cross multiply. This is like saying all over 1. This multiplied by this, and this multiplied by this. We have 28 h equals 3 times 70. 28 h will give us 210. 3 times 70 is 210. We now divide both sides by 28. Remember, we are looking for our height. For us to get our height, we must divide both sides by 28. So we have 28h over 28 equals 210 over 28. Of course, if we count 28, we are left with our height. So our height, we have 210 over 28. We cancel out. 7 into 28, we have 4. 7 into 210, we have 30. 2 into 4, we have 2. 2 into 30, we have 15. We have 15 over 2, which is the same thing as 7.5. So our height is 7.5 cm. 7.5 cm. Let's just brush through it. We are given a volume of 70 cm cube, a base area of 28 cm square, and we have to find the height. Since we know the formula already, 1 over 3 times base area times height, so we make substitution. This will now equal to our 70 cm cube. So 1 over 3 times our base area of 28 cm square times height equals 70 cm cube. So 1 times 28 is 28 times our height is 28h all over 3 equals our 70 cm cube. At this point, we cross multiply. This multiplied by this and this multiplied by this. This gives us 28h equals 3 times 70. And 3 times 70 is 210. We now divide both sides by 28. As you can see, 28,028, we are left with our height equals 210 over 28. 7 into 28, we have 4. 7 into 28, we have 4. 7 into 210, we have 30. 2 into 4, we have 2. 2 into 30, we have 15. So we have 15 over 2, which is equal to 7.5 cm. We convert this to decimal, we have 7.5 cm. So our height is 7.5 cm. Okay, let's look at another example. A pyramid 8 cm high stands on a rectangular base 6 cm by 4 cm. Calculate the volume of the pyramid. Our height h is 8 cm. It stands on a rectangular base 6 cm by 4 cm. So our volume, we know already, is 1 over 3 times base area times height. So we have 1 over 3 times, this one is a rectangular based pyramid, and know that the base is a rectangle and the area of the rectangle is length times breadth. That's 6 times 4 cm. So we have 6 cm times 4 cm. Then times our height of 8 cm. Our height of 8 cm. So at this point, we divide 3 into itself is 1, into 6 is 2. So we have 2 cm times 4 cm times 8 cm. That's 2 cm times 4 cm times 8 cm. 2 times 4 we have 8, and 8 times 8 we have 64 cm cube. 64 cm cube. That's the volume of that pyramid. We have a formula 1 over 3 times base area times height, and I said it's a rectangular base pyramid, and as such the base is rectangular shaped. So we say it has measurement 6 cm by 4 cm, and a rectangle has an area of length times breadth. We calculate the area of rectangle by saying length times breadth. we have 6 cm times 4 cm. So that's our base area. 1/3 times 6 cm times 4 cm times our height, 8 cm high, our height of 8 cm. So at this point we divide and cancel out. 3 into itself is 1, into 6 we have 2. So we now have 2 cm times 4 cm times 8 cm. As we have here 2 cm times 4 cm times 8 cm. 2 times 4 we have 8, 8 times 8 we have 64. We have 64 cm cube as the volume of that pyramid. So the next we look at is surface areas and volumes of prisms. Surface areas and volumes of prisms. Yes, we are looking at surface areas and volume of prisms. And we already know that cubes, cuboids, and cylinders are examples of prisms. The volume of a prism is denoted by the formula we have on the board: area of uniform cross section times perpendicular height. Or you can say area of the base of the prism times height. Okay, let's look at this figure on the board. The figure below shows a wooden block in the form of a prism. Now we have a wooden block that is carved in the form of a prism. We say PQRS is a trapezium. We have PQRS. This shape is trapezium. And we say that PQ is parallel to SR. PQ is parallel to SR. These two lines are parallel to each other. And we say PQ is 7 cm and PS is 5 cm. SR is 4 cm. Now the block is 12 cm long. We have to calculate the volume. Our formula again is the area of base times height. And if you look at this shape, the base is a trapezium. So we find the area of the trapezium and multiply by our height of 12 cm. So we say volume of block will give us area of PQRS, that's PQRS, this trapezium, then times our height of 12 cm, times our height of 12 cm. Okay, we first find the area of the trapezium. Area of trapezium is given as 1/2 A plus B times height. Half A plus B times height. Now, in this trapezium, we have our A, we have our B, but the height is not given. The height should be this side, and it's not given. So we make this demarcation. Now, we split this trapezium into two shapes, a rectangle and a right angle triangle. We are now to find our height. These two are the height. How do we find this height? Since this 4 cm, line SR is 4 cm, from Q to this point here should be 4 cm. Before I explain further, let us withdraw this trapezium. We withdraw it. We have here to be 4 cm, this is our SR. We have 5 cm, that's PS. And PQ we say is 7 cm, but we have demarcated. So by this demarcation, this should be equal to this. So we have here as 4 cm and this point as 3 cm. We have here, the whole of this is 7 cm and here is 4 cm. That means from this point to this point should be 4 cm. Then from here to here is 3 cm. So now what we have here, 4 plus 3 gives us 7. How do we find the height? We apply Pythagoras rule because this is a right angle triangle. We say that the square on the hypotenuse is equal to the sum of the square on the two other sides. That's h square plus 3 square equals 5 square. That's Pythagoras rule. H square plus 3 square equals 5 square. So we have h square plus 9 equals 25. 3 square is 9, 5 square is 25. So h square will be equal to 25 minus 9. H square will give us 16. Since our h square is 16, our h will give us square root of 16. So our h is 4 cm. That means that our height here is 4 cm. This dimension is 4 cm as well as this. So our height is 4 cm. So at this point we can now apply our formula for the block. We say the area, the volume of the block is given as area of base times height. We can now find the area of this trapezium by applying this formula because we now have our height of 4 cm. So half our A is 4 cm plus our B. Our B is the whole of this 7 cm. This A, this B, and this is our height. So we have half into bracket 4 plus 7 times our height. We now have our height as 4 cm. 4 cm. So this will give us half times 11, 4 plus 7 is 11 times 4 cm. 2 into itself is 1, into 4 we have 2. So 11 cm times 2 cm will give us 22 cm. Okay, we have the area of our base as 22 cm. But remember that the volume we say is area of base times height. Area of base times our height. We already established this, and we have a height of 12 cm. So we multiply our base area by height. The 22 cm square, this should be square, but this is area of a shape times our height of 12 cm. 22 cm square times our height of 12 cm. If we multiply this, we will get 264 cm cube. 264 cm cube. Let's run over it again. We have a figure on the board. We say that the figure below shows a wooden block in the form of a prism. PQRS is a trapezium. The base is a trapezium. And we are told that PQ is parallel to SR. That's line PQ is parallel to SR. Line PQ has a length of 7 cm. PS is 5 cm. And SR is 4 cm. The block is 12 cm long. We have it on the board. Then we have to calculate its volume. And we know that the volume of a prism is given by multiplying the base area by height. And we know that the base here is a trapezium. We have a trapezium on the board. We apply the formula for finding the area of the trapezium. Half into bracket A plus B times height. But from our base, the A is given and B is given, but the height is not given. So what do? We redraw the base. Since we have our SR to be 4 cm, we demarcate, we separate this shell into 2. Since we have SR to be 4 cm, from this point down is 4 cm. Because one property of a rectangle is that the opposite sides are equal. So we have 4, or a square, that the opposite sides, or for a square, all the sides are equal. For a rectangle, the opposite sides are equal. So we have 4 cm, 4 cm. Since PQ is 7 cm, so for us to get this part, 7 minus 4 gives us 3. So we have 3 cm and we have a hypotenuse. For us to get our height, we apply Pythagoras rule because we are dealing with a right angle triangle. So we apply Pythagoras rule. Pythagoras. As the square on the hypotenuse is equal to the sum of the square on the 2 other sides. So h squared plus 3 squared equals 5 squared. That's h squared plus 3 squared equals 5 squared. And we have our 3 squared to be 9, our 5 squared to be 25. So h squared plus 9 equals 25. We collect like terms. H squared will be equal to 25 minus 9. And that gives us 16. So our h squared is 16. Therefore our h will be square root of 16, which is 4 cm. So we have a height of 4 cm. So, having gotten our height, we apply our formula for area, half A plus B times height. That's half into brackets A plus B, that's 4 plus 7. This is 3 plus 4, 7. Then times our height of 4 cm. So 4 plus 7 gives us 11 times our height of 4 cm. 2 into itself is 1, 2 into 4 is 2. So we have 11 cm times 2 cm equals 22 cm squared. This is the area of the base, just the area of the base. We now multiply by our height to get the volume. So we have 22 cm squared times 12. If you multiply that, we have 264 cm cubed. So the volume of our prism is 264 cm cubed. Okay, let's look at another example. Calculate the volume of the shape below. Calculate the volume of the shape below. As you can see, the shape we have here is a prism, a triangular base prism, because the bases are triangular shaped. So we have to calculate the volume. How do we do this? We apply a formula. We say our volume is given as our base area times our height. And since we say it's a triangular base prism, the base is a triangular shape. And the formula for finding the area of a triangle, we say is area of triangle. We say is half base times height. Half base times height. We have our base as 8 cm and our height as 6 cm. Then for volume, to be the area of triangle times our height of 20 cm. So we say volume is equal to half base times height. That's half times our base, we have 8 cm, times our height, we have 6 cm, times the general height of the prism, 20 cm. So we cancel out 2 into itself is 1, into 8 we have 4. So we now have 4 cm times 6 cm times 20 cm. That's 4 cm times 6 cm times 20 cm. Multiply through 4 times 6 we have 24. 24 times 20 we have 480 cm cubed. Let's run through it again. Calculate the volume of the shape below, and we say that the shape is a triangular prism. The base of the shape is triangular shape, is triangular in shape. And we say that for a triangle, the formula for finding the area of a triangle is half base times height. Remember, our volume is base area times height. So we deal with our base area first. Our base is a triangular in shape, and we have the area half base times height. That is half times our base of 8 cm times our height of 6 cm. Then times our height. For volume, we have the height of 20 cm. We have a general height of 20 cm. So we say volume is half times base times height of the triangle, then times our general height of the figure, which is 20 cm. So 2 into itself is 1, into 8 we have 4. So 4 cm times 6 cm times 20 cm. 4 times 6 we have 24, and 24 times 20 we have 480 cm cubed. So the volume of our triangular base prism is 480 cm cubed. 480 cm cubed. Okay, let's look at surface areas and volumes of cones. You can see our figure of a cone on the board, and we have the formulas here. The formula for finding or calculating the curved surface area, we have this pi r L, and the total surface area we have pi r L plus pi r square. You know that a cone has a circular base, and the area of the circle is pi r square, while the curved surface is pi r L. The curved surface we have pi r L, and the circle is pi r square. So our total surface area is this plus this, pi r L plus pi r square. Pi r L plus pi r square. Then the volume is given as 1/3 times pi r square h. Now we apply the formula in solving problems. We have on the board, calculate the volume of a cone of base diameter 14 cm and height of 5 cm. We have our diameter of 14 cm, we have our height of 5 cm, and we have pi as 22/7. We have to find the volume, and we are told that volume is 1/3 pi r square h. That's the volume of a cone, 1/3 pi r square h. So our diameter is given as 14, so radius will be diameter over 2, that's 14/2 cm. That will give us 7 cm. So we have 1/3 times Our pi, we are told to use 22/7 times our radius of 7 cm times 7 cm times our height of 5 cm. 1/3 pi r square h, pi 22/7 times our radius 7 cm times 7 cm times our height of 5 cm. So at this point we cancel out. 7 to itself is 1, 7 here is 1. So we now are left with 22 times 7 times 5 all over 3 all cm cubed. We have 22 times 7 times 5 all over 3 all cm cubed. So at this point we will multiply through. 22 times 7 times 5 will give us 770 all over 3 cm cubed. We use our calculator to divide that, we get 256.67 cm cubed, approximately 260 cm cubed. We have to round it up to the nearest tens. Or to the nearest tens we have, or the two significant figures, we have 260 cm cubed. So the volume of that cone is 260 cm cubed. Okay, let's look at this. Calculate the total surface area and volume of the shelf below. Calculate the total surface area and volume of the shelf below. We have our cone shape. We have a base diameter of 7 cm and a height of 6 cm. So we have a height of 6 cm. We have a diameter of 7 cm. We know that our radius, given as diameter over 2, that's 7/2 cm. Then, okay, pi is not given, but we use pi as 22/7. So we begin with the total surface area before we go to the volume. So our total surface area, we say is pi rl plus pi r squared, and we factorize this to get pi r into brackets length plus r. So we apply this to get our total surface area. So pi is 22/7 times our radius of 7/2 into brackets L, our slant height, plus R. Where is R? R of 7/2. But in this case, our slant height is not given. Our slant height is not given. But we can see that we have a height, and we do this. We now form a right angle triangle. Since this is 7 cm for diameter, radius will now be 7/2, which will give us 3.5. So the radius is 3.5. So our L now forms our hypotenuse of this right angle triangle. So we now apply Pythagoras rule to get our slant height. So we say, using Pythagoras, the square of the hypotenuse is equal to the sum of the square on the two other sides. Now the square of the hypotenuse is equal to the sum of the square of the two other sides of a right angle triangle. So L square will be equal to 6 square plus 3.5 square. So we have L square is equal to 6 square plus 3.5 square. So we have that L square with 6 square we have 36 plus 3.5 square should give us 12.25. 12.25. So if we add this together, we have 48.25. Our L square is now 48.25. L will be square root of 48.25. Use your calculator. Square root of 48.25, we have 6.95 cm. So our length is given as 6.95 cm. It's at this point that we now find the total surface area. Remember, at this point there is no slant height, so we now go again. Pi r as 22/7 times our radius of 7/2 into brackets our slant height now 6.95 plus our radius 7/2 is 3.5. all cm. I'm applying this formula for total surface area, pi r into bracket L plus R. So we have pi 22/7 times R 7/2 into bracket L. We now have our length as 6.95, then plus R again 7/2, which if we divide 2 we have 3.5. So at this point we now cancel out. Before we cancel out, okay, 7 into itself is 1, 7 here is 1, 2 here is 1, 2 here is 11. So we have 11 into bracket 6.95 plus 3.5 all cm. Now we simplify our bracket by adding that. If we add, we have 11 into bracket 10.45. If we add 6.95 to 3.5, we get 10.45. We now multiply this by 11. We multiply this by 11 to get 114.95 cm squared. 114.95 cm squared. This by approximation we have 115 cm squared to the nearest cm squared. So that is our total surface area of our cone. We are left with the volume of the cone. But let's run through the total surface area again. Okay, we have our cone and we are defining the total surface area. We have the formula pi r into bracket length plus r. So we have that from our question, we have pi 22/7 times our radius. Radius is 7/2. 7/2 into bracket our length, which is not given, plus our r of 7/2. So we make this a right angle triangle so that we can find our hypotenuse. So using Pythagoras rule, L square will give us 6 squared plus 3.5 squared. 6 squared is 36 plus this square will give us 12.25. If we sum this, we get 48.25. So our length will be square root of 48.25. We get 6.95 cm. So our slant height is 6.95 cm. We now apply our formula. This by addition. This plus this, we have 10.5 cm. Multiply everything by 11 to get 114.95. And by approximation to the nearest whole number, we have 115 cm squared. Next is to find the volume of the shape, and we have our formula 1/3 pi r square h. So we say 1/3 times our pi is 22/7 times our radius 7/2 times 7/2, because r is squared multiplied by itself, times our height of 6 cm. Our height of 6 cm. So at this point, what do? We cancel out. 3 here is 1, 3 here is 2, 2 here is 1, 2 here is 1. We are left with 22 times 7 times 7 all over 7 times 2. That's 22 times 7 times 7 all over 7 times 2. 7 will cancel 7 one time. 2 into itself is 1. 2 into 22 we have 11. We have 11 times 7. That will give us 77 cm cube. So the volume of that cone is 77 cm cube. Let's run over again. We have the formula 1/3 pi r square h for volume of a cone. Our pi is given as 22/7. Our radius is diameter over 2, that's 7/2. Then our height is 6 cm. So we have 1/3 times pi times radius squared times 6 cm. 3 into itself is 1. 3 into 6 is 2. 2 into itself is 1. 2 into itself is 1. So we are left with 22 times 7 times 7 all over 7 times 2. Or we have 22 times 7 times 7 all over 7 times 2. 2 into itself is 1. 2 here we have 11. 7 here is 1. 7 here is 1. So we now have 11 times 7, 77 cm cube. So the volume of that cone is 77 cm cube. Next is your assignment. Alright, you take down this assignment. Calculate the curved surface area, total surface area and volume of a cone giving diameter 7 cm and height of 16 cm. And you are to use pi as 22/7. Number 2, calculate the volume of the shells below. You have 4 shells on the board. You have a triangular base prism, you have a cylinder, a cuboid, and a cone with their dimensions. So you have to calculate their different volumes, applying the appropriate formula. With this, we are come to the end of the class. Please ensure to do your assignments. So many of you are yet to submit your previous assignments. So I'm expecting them soon. See you next week.